Good morning, Course 1. Welcome back. Mr. Belke here with you to solve some two-step equations. This is lesson 106, found on page 553. We're getting into some algebra here today, folks. So let's take a look at example 1. If I have 3n minus 1 equals 20, okay? Some number. If I multiply by 3 and I subtract 1, I will wind up with 20. And I want to find out what that number is. Now, some of you might just be able to look at it and say, well, Mr. Belke, that's 7 because 3 times 7 is 21. 21 minus 1 is 20. You're right. But there's going to come a time when these problems will get much more difficult, more challenging. And so you'll need to be able to use a process to figure out what the answer is. And today we're going to be working on that process. So the process is going to try and isolate the variable. We want to get the variable by itself. And today we're going to need to do two steps to that process. Okay? So in order to get n by itself, the first thing that I need to do is to get rid of this 1. Okay? So instead of subtracting 1 to cancel that out, I can add the opposite, right? The opposite of 1 is 1. So instead of subtracting 1, if I add 1, those two things will cancel out. But whatever I do on this side of the equation, I also have to do over here because I got to keep the two sides balanced, right? If I have a scale and I have, some things on that side of the scale and some things on that side of the scale, if I take something away from this side, I have to take something away from this side in order to balance it. Or if I add something to this side, I have to add something into this side in order to keep it balanced. Otherwise, the scale will tip over. All right, so to balance it, this fulcrum is like the equal sign. Okay, and I got to keep both sides balanced because this side is equal to this side. So if I'm adding 1 on this side, I got to add 1 on this side as well. So now I'm left with 3n. And on this side, I'm left with 21. So 3 times n equals 21. So to get n by itself, instead of multiplying, I use the inverse operation. The inverse operation of multiplication is division. Divide by 3. And that'll cancel out. But if I divide this side by 3, I also have to divide this side by 3 to keep it balanced. So divide by 3. So that leaves me with n on this side, because 3 divided by 3 is 1. 1 times n is n. And on this side, 21 divided by 3 is 7. Therefore, n equals 7. And I could plug that in. 3 times 7 is 21. 21 minus 1 is 20. So that works. Okay? And that's what we're doing today. Let's take a look at another one. Let's see. Let's do 3y minus 2. Actually, let's do 5m plus 3 equals 33. 5m plus 3 equals 33. Okay, so again, I want to isolate. I want to get m by itself, and I got to keep both these sides of the equation equal. So first thing I'm going to do is I'm going to get rid of these 3. So if I have 3 positives, I want to get rid of them by subtracting. Inverse operation. The opposite of adding 3 would be subtract 3. So if I subtract 3, positive 3 minus 3 cancels out to nothing. But if I subtract 3 on this side, I got to keep it balanced. Subtract 3 on this side. Okay, so now I'm left with 5m equals 33 minus 3 is 30. 5m equals 30. All right, so now to get m by itself, divide by 5 and divide by 5. 5 divided by 5 is 1. 1 times m is m. And on this side, I have 30 divided by 5 is 6. Therefore, m equals 6. I can check it by plugging it in. 5 times 6 is 30. 30 plus 3 equals 33. And that checks out. So that tells me that my answer is correct. That's all there is to it. You're just using inverse operations to solve these problems. As always, if you have any questions, feel free to call, text, or email me, or meet me online tomorrow between 9 and 10 o'clock. Have a fantastic day.